Welcome to this week's episode of Research Goes Viral. We're here at the CVR. My name is Spiros Litras. I'm co-hosting with Kieran Lamb with me. We have a very special guest today, all the way from Canada. Angela Rasmussen is visiting the CVR and Glasgow as well. Angie did her PhD at Columbia University and then went to University of Washington, then back to New York briefly, and has now settled down to, I'll probably need some help with the pronunciation, University of Saskatchewan?
Close enough, yeah, Saskatchewan.
Saskatchewan, there we go. Where she's a professor at the Vaccine and Infection Disease Organization, also called VIDO for short.
VIDO.
So welcome.
Thank you for having me.
Absolutely. First time in Glasgow?
It is my first time in Glasgow. It's my first time in Scotland.
Great. How are you finding so far?
I like it, but I'm originally from the Pacific Northwest, so gray skies and rain feels like home to me.
Excellent.
Very pretty, though. Lovely and great food.
Yep. You got some rain, I think, but I think
some rain.
The weather's getting slightly better today.
Yeah, it
started off on kind of a bad foot with like a really rough flight in, and airline lost my suitcase, but now I've got my suitcase and I'm on solid ground, so I'm all good.
That's why you never go to the seminar the day right after you fly.
Right. Yeah, I was relieved that I got an extra day in between to recover.
Yep, it's really good.
So you recently moved to Canada, like about 2 years ago, right?
2.5 years ago, yeah.
So how have you found that, and what's it been like changing?
I mean, it's very different. Like, I think a lot of people think that like Canada and America aren't so different, and in many ways they're not. But there are, apart from the accents, there are very clear differences, and the spellings. Like, I've had to try to learn how to spell everything with a U that I didn't spell with a U before, like color and honor and...
That's more like us then,
Yeah. They use Canada is a Commonwealth country, and I've also had to get used to lots of British royal stuff.
Of course, yeah.
Yeah, one of our neighbors has like flags that they fly with like the Queen's Jubilee. They had like a Queen's Jubilee flag and the coronation flag, and sometimes they just fly a good old Union Jack.
Of course.
I don't think I've seen them fly a Scottish flag. But apart from that, I mean, it's nice. Like, the Mexican food is not good in Saskatoon, and the pizza's good depending on where you go. And it's definitely, the weather's very, very different. But there's many things about Canadian culture that I think are better. It's similar but different. But I think we've adjusted. My husband really likes hockey, and so Canada's the place to be for that. And I have to say, Saskatoon is, a more rural place than I've been living recently. I grew up in a town that is not huge. It's about an hour southeast of Seattle. But since graduate school, really for the last 20 years, I've been living in like basically New York or Seattle. So big cities, and Saskatoon is definitely not that, but it punches above its weight. I think there's a really nice art museum. There's interesting people. I've met a lot of friends, both in and outside of work. And it's a really nice community to kind of set down roots. And I'm, I guess, at that stage in my life now where I don't need as much bright lights and big city as I need, like, nice house and fireplace and place for my dogs to run around. And Saskatoon's great for that, except for the 4 months out of the year that it's like a frozen hellscape.
Yeah.
And I don't think I'll ever get used to that, but it's not the entire year, and the summers are quite lovely.
Okay, so what's the spring like, right? So if you've got minus 40 in the winter and then like lovely summers, is it a gradient, or does it very quickly shift?
The first spring that I was there, the snow thawed out in early March. Last spring, it didn't stop snowing and thaw until May.
Wow, okay.
There was still snow on the ground when I went to the Nidovirus meeting in Switzerland in mid-May.
Right.
That was me.
Yeah. Yeah, it's It can be pretty brutal. And I guess some years, like, there's not very much snow at all because it actually is quite dry. It's, that was actually another thing that I really had to get used to. I probably spent a lot of money on beauty products. I'm kind of afraid to tally up how much I spent until I found moisturizers that would actually work. Because it is really dry. But some winters it's so dry there's not really very much snow. It's just that it's so freaking cold that once it freezes, like in late October, early November, it basically doesn't thaw out again at all until like the first thaw, which can be anywhere from March until May.
Wow. You touched on a point that was really interesting about kind of settling down. I think a lot of kind of early career researchers listen to the podcast or watch the podcast. And, you know, how does that feel? At what point in your scientific career do you feel like you need to kind of settle down? And how does it feel to kind of move around? Because I think a lot of, especially kind of young scientists, need to do that a lot for a continuous academic career, right?
Yeah, so I made choices in my career that were not really the conventional ones. You know, I got my PhD and then I did a postdoc and then I didn't really go anywhere. In fact, I tried to quit my lab and long story, I thought my boss was going to fire me. He's no longer in science, but I thought he was going to fire me because I can't even remember what he was upset with me about. But I said to myself, I got to break up with him before like he dumps me, professionally speaking. And so I went in and told him I was quitting, and he was so surprised that he offered me a promotion and a significant raise. And so I decided to stay. And 2 years later, he offered, well, I said that I was thinking that it was time to move on to a faculty position or some type of principal investigator position. And so he then hired me into my first faculty position. So that's not really the way that people do it a lot of times, or that it's been done traditionally, which is you do your PhD, your postdoc, and then you go on the academic job market and do that whole arduous and torturous process, and then you get a tenure track position, and hopefully you get tenure, and then you're set for life. I mean, I think that paradigm is changing because there's a lot more PhDs who want an academic career than there are academic positions available for them and funding for those labs. I also think that schools, for a variety of reasons, are doing away with tenure. And I continued down sort of a non-traditional path because then I said, finally, there's no way I'm going to get a tenure track position at the University of Washington because of like their hiring plans in the department, which I knew about because I was a member of the department. And I didn't want to be like non-tenure track faculty who was always going to be that dependent on either somebody else's grants or, you know, basically not having a lab and potentially not having a job if my money ran out. So I started applying for tenure track positions, and then a variety of things happened with my former toxic boss. And I was offered a faculty position at a pretty good school, but it was in a place in the U.S. that would have been challenging for me to live in terms of my personal life. So I decided that I would instead be recruited at Columbia into yet another non-tenure track faculty position because I could take all of my grant money with me, which was at the time pretty significant. I had funding from NIH and from 2 different Department of Defense agencies. So, and I was able to keep some of my team together. I was able to move to New York, and I already knew that I liked New York, and it was going to be a lot easier to go back and forth between New York and Seattle than it would be from the other options that I had. But then 4 years later, the tenure track position that I had been assured would be easily attainable turned out not to be. as easily attainable. And I also turned out to have gone from one toxic boss to another. And this toxic boss was one who mistreated me, in particular because of my gender, and subjected myself and a lot of other people in the lab to pretty discriminatory bad treatment. Not to mention that commuting cross country once a month at least was expensive and incredibly exhausting. And not that I should talk because I clearly haven't learned my lesson about traveling too much these days, but at least I'm not traveling like just to see my family and really just to go home. So at the beginning of the pandemic, I thought to myself, like, well, I'm already looking for another position, one that ideally would be in a place where both my husband and I could live once my younger stepson goes off to college and we're no longer sort of restricted just to the Seattle area. And so then the pandemic happened and I had to make a choice. Like, am I going to stay by myself in New York with no clear timeline for being able to do work that would actually contribute, other than making diagnostic PCR, which everybody was doing and which, in my view, wasn't particularly innovative or useful, or staying in Seattle and working on writing papers, writing grants, working on collaborations with COVID, or novel coronavirus 2019 at the time.
That's right, that was the name.
and thinking about what my next move was going to be. And so that was a no-brainer to me. It was more important for me to be with my family and to be in a situation where I was at least going to be around the people that I cared about. I'm from the Seattle area originally, so my parents were nearby, my niece and my brother. So it just made sense to do that. And over the course of that time, I started doing science communication just because I was writing grants and papers and trying to get collaborations up and running. And in the course of that, I was reading a lot of the preprints that were coming out, but I was also seeing like how much, frankly, bullshit was coming out. And I thought that was like something that I could do that would be genuinely helpful because everybody was really freaked out. And I'm not necessarily the person who's going to be the best to explain epidemiology, but an epidemiologist isn't going to be the best person to explain how novel coronaviruses work. And I've been working on MERS since 2013. So I did feel like I could contribute in that way. And through that, I actually heard about my current position, which, for an early career researcher who's thinking about this, I just say that don't beat yourself up if like your career doesn't go the way that you think it should or the way that careers are traditionally supposed to work. Because I found out about this position, actually one of my collaborators from my MERS days was a PI at Vito, and now he's my colleague. But so I knew about Vito, but I didn't realize they were hiring, and I was like, what? I don't even really know where Saskatoon is. Like, what kind of a name is Saskatoon anyways? Saskatchewan's like the prairies. I'm from a place with salt water and mountains and like not cold winters and comparatively.
Yeah.
And it was taking a chance, but I think that people should really keep an open mind to it because even though it's not a tenure track position, there's no tenure at Vito where my primary appointment is. Now I run my own lab. Mm-hmm. It's the opposite of the former toxic workplace cultures that I was involved with. It's wonderful to be in a place that really wants me to be there and is excited about me being there and has been recruiting other colleagues who I'm excited to work with. and has excellent facilities. We operate one of the largest containment labs in North America, which means that for the first time in my career, I can finally really do my own work with the pathogens that I work on rather than relying on collaborators. And as we are upgrading to BSL-4, I will be able to do my own Ebola work as well. So long term, I'd say to people, if just because you didn't get that tenure track position that you were thinking about, or maybe you don't even know if that's what you want to do, I don't think there's one right way to do it, because I think arguably I've been very successful in ways that some people, some of my colleagues and friends who've gone the more traditional path have not. Yeah. And especially I think for women, for queer people, for underrepresented people, minorities, people of color, I think that sometimes that traditional path is not always as accessible to you. Yeah. And part of my reasons for not taking that traditional path was because I had two really shitty bosses. And I'm here in spite of them. And so I think that it's also totally okay to remind people that just because of somebody else's failures, you didn't end up like where you thought you should be or somebody else thought you should be, doesn't mean that you can't be successful and have a very satisfying career where you contribute a lot of meaningful work.
This is really valuable advice especially for early career researchers. You touched on science communication, and I think we'll go back to that in a little bit. I was gonna try and briefly get the science out of the way first. And so you've mentioned Vito, you've mentioned plans for BSL-4. We saw your seminar a couple of hours ago talking about your really, really interesting work. So essentially what I want to ask is, what is the outlook of the lab? What are you studying, and what are you excited about to work on?
I hope that the outlook of the lab is good in the sense that I continue to have sustained grant funding, which is really what everybody should worry about. If I give advice to early career researchers, it's make sure that you get some experience writing grants and that you pick topics that are likely to be funded, because ultimately in most jobs, whether tenure track or not, whether a state or provincial school or not, you're always going to need to make sure that you've got the funding to not just do your work, but also continue to pay your trainees. And to me, one of the things I care about even more than the science is making sure that, I don't have to let any of my people go because I can't afford to pay them. And now, granted, at my institution, I don't think that would happen to trainees, but nonetheless, it's something that I think about constantly. It's important to do great work, but to do that, you have to have money. And to do that, you have to have people that you're going to pay with that money. That's always first and foremost on my mind. But scientifically, what I'm excited about, frankly, is working on something besides just SARS coronavirus 2, which I work on it and think about it every day. Obviously, COVID is still important. It's still a public health problem. It's still something that my research is going to focus on for years to come. I have multiple COVID projects in the lab. And I do think there's big knowledge gaps still, especially when it comes to the role of the host in pathogenesis, especially when it comes to susceptibility of other species. And if we ever really hope to control COVID, I think that those knowledge gaps need to be filled. But I'm really tired of talking about COVID all the time. I'm really tired of thinking about COVID all the time. Because one of the things that my side work as a science communicator has brought on is that people ask me all kinds of questions about COVID that I'm not the right person to answer. Mm-hmm. And I've had to tell people over and over again, I have no idea what the ICUs are like because I'm not a physician. Nobody's going to let me anywhere near a patient. I also am not going to comment on, population epi, or even phylogenetics, if it's like a really in-depth question requiring technical expertise, because even among virologists, there are different areas of expertise. And mine is more, how does the virus replicate, pathogenesis, fitness, the real nuts and bolts of virology and how that works within the context of different hosts. And I mean, I talk a good game about being like systems biologists, but at heart, like I'm a classically trained virologist. And that's what I like to talk about and think about. So it's really nice to think about viruses that are not just SARS-2, because there are a lot of other viruses that are really important pathogens, both to humans and to animals, that we haven't paid enough attention to. And one of the biggest problems I see, and you tell me if this is true in the UK, but it's true in the US and Canada, is that a lot of the pandemic research that was those investments that were made at the beginning of the pandemic, I hoped would be sustained. And they're not, which means that not only is there less money now for doing SARS-2 work, and again, by money, I don't mean money, I mean trainees and science to do. But there's also other viruses. I mean, there's a Nipah outbreak going on right now in India. There could be other Nipah outbreaks. There will be other outbreaks. There's, MERS pops up here and there. Ebola has been popping up more and more often in a most unwelcome way. There have been breakthrough Mpox infections, and Mpox has never been resolved.
Yeah.
In endemic countries, people don't have access to Mpox vaccines. They don't have access to tecovirimat. These viruses that people in the wealthy world, largely the global north, worry about they remain problems even after we've solved them in places where we can afford the solutions. And we still don't invest enough in the solutions, even when we can't afford them. So I think that, I'm looking forward to hopefully thinking of new ways to address some of these challenges, both scientifically and in terms of communicating to the public the importance of addressing and solving these problems.
That's really important. I mean, we had the same problem in the UK. Infrastructure that was kind of built up for SARS-CoV-2, surveillance, for example, or looking at kind of patient-specific samples and having all that resolution of data. We saw the schemes getting kind of, someone pulled the plug on a single day. They were like, oh, that day, that's done.
Yeah.
Instead of continuing it for whatever comes next. I'm sure that some of the infrastructure will remain, but the actual funding schemes are gone.
Yeah. And you know what? You can have all the sequencers in the world, all the high-performance computing clusters to process all that data. But if you're not maintaining that, if you're not maintaining the staff that's needed to run that, if we could have robots and sequencers like do all of virology for us, we would. But we obviously can't. Like, those are all tools that people need. And in order to have people continue to operate them with, expert knowledge and hopefully to grow while they're doing that, such as trainees like yourselves, and frankly, me until not that long ago. I mean, it's amazing how fast you get old, but I feel like it was 10 years ago that I was a postdoc, but I mean, it doesn't feel like it's been that long. You need to actually make these investments to have this type of thing work over the long term.
Yeah.
And it can't be done on a country by country or region by region basis either. It needs to be done in a way that is equitable and that also makes sure that there's talent and expertise where it's needed, which right now isn't always just the US and Europe and Canada and the UK and Australia. It's a lot of places around the world where that doesn't exist. And I guess I was supposed to be talking about stuff that I'm excited about. This is not stuff I'm excited about, and it's stuff that I'm pissed off and depressed about. But I do think that it's important to discuss it and to think about it, because really we need to be thinking about solutions for it.
Yeah.
How do you think, given that we are kind of almost short-sighted in that kind of respect, we have, like you said, we've had the pandemic, we've had almost like a massive resource of kind of people working on it and money thrown into it. It's almost, I guess, it's quite important, and I think you've been exemplar in that and trying to communicate that to the public. How do you think we almost communicate that to the kind of funding bodies or the people who are providing the money to be a bit more long-sighted in that approach, right? Because, you know, that level of response for COVID we don't necessarily have in the future, we would hope, and even just continuing that and making sure it expands beyond just one virus, for example.
Oh, well, you guys are asking really easy questions. You know, I wish I knew. I think that one way, at least that I've tried to approach it, is by continuing to talk to the public and the press about it, and to make sure that people are even aware of it. Because I think, from my perspective, coronaviruses are a great example, right? Like, we saw SARS coronavirus 1 emerge when I was... actually, that was before I was in grad school, but, you know, we watched that happen, and in the U.S., where I was at the time, the U.S. government put a ton of money into funding coronavirus research, and specifically sarbecovirus research, or SARS-related coronavirus research. A lot of people switched to working on coronaviruses, which at that point, you know, they're important veterinary pathogens, and as somebody who did her PhD on rhinovirus, like, don't sleep on the common cold. Like, it is a huge economic problem, and it can kill people with pre-existing conditions that predispose them to more severe respiratory disease. But, you know, it was not regarded as like a big popular family of viruses to work on. It wasn't like HIV or influenza or HCV or, you know, a virus that was thought to be it wasn't a family of viruses that were thought to be a huge problem. And SARS coronavirus 1 changed all that because people realized its potential to cause a pandemic. And a pandemic, more importantly, that had a high mortality rate associated with it. But turns out, fortunately, we could control SARS-1 largely by screening for symptoms and by adhering to sort of standard isolation and quarantine practices. And outbreaks, I mean, technically, SARS-1 was sort of a pandemic because there was spread in 2 continents at the same time, but it didn't become a pandemic, like in the way that I think everybody understands what a pandemic is. It certainly didn't cause anything like this. It infected about 8,000 people. It killed about 800 people. Now, I don't think 800 people is a trivial amount. That's a lot of people, but it's not the same as deaths in the millions. It did not cause the same kind of damage as SARS-2 has. Yet, at the time, people freaked out about it. But then, when they saw that, well, you know, it's not as bad as we thought it was going to be, and it just kind of went away. I mean, it evolved into something else, but it didn't cause any more human disease after 2003. And so I think all of those grants that were funded by the NIH to study this understudied family or subgenus, in this case of coronaviruses, went away. And a lot of people went back to working on whatever they were working on before they started, you know, their new coronavirus research program. Of course, there are some notable exceptions, but, you know, by and large, a lot of the work, especially vaccine development work, you know, looking for antiviral drugs, even just trying to understand sort of basic fundamental biology about how SARS coronavirus 1 worked, got shelved. And then also, because of 9/11, SARS became, in the U.S., a select agent, which means that fewer and fewer labs could actually work on live SARS coronavirus 1 virus. Now then, MERS emerged in 2012, and that was also a huge concern, and an even bigger concern because MERS has a higher mortality rate than SARS. It was also a novel virus in the sense that a virus in that particular subgenus had never, well, the subgenus didn't really exist until MERS because it's called MERS-like coronaviruses. But that type of virus, of coronavirus, beta coronavirus, had never caused human outbreaks before that had been observed. So again, the same thing happened. A lot of money went into it. A lot of people started working on it. And then, again, the same thing happened. We realized that MERS wasn't spread from human to human very efficiently outside of certain situations in hospitals, for example. So a lot of that MERS money went away too. And again, people went back to working on whatever they were working on. I thought to myself in the spring of 2020, like, it's never going to happen again. Like, third time's a charm, I guess. And, you know, this time people will understand that they need sustained investments in these pathogens. And now, you know what? SARS-2 is here to stay. Like, we're not getting rid of this virus anytime soon. If everybody wore N95 masks, like, 24/7, even when they, like, slept and showered, we would still have SARS-2 circulating. And the reason for that is that there are infected animals all over the place. We don't even know all the animals that are infected. And people don't think they interact with the natural world very much, but people interact with wildlife all the time. Even in the UK. I bet you guys have, like, deer and stuff that run around back there. Yeah. I mean, you guys are at a vet school. Like, you guys have animals all over the place.
Yeah.
And
deer along the motorway quite often.
You know, yeah, exactly. In cities, I mean, you know, in New York, like, you go to Central Park and you can see all kinds of birds, all kinds of little critters and squirrels.
It's in the middle of a city, right?
Yeah, in the middle of, like, a huge city of 8 million people. You know, I mean, Central Park is big for New York, but overall, like, New York is not that big of Manhattan's not that big of an island. And certainly Central Park does not make up the majority of it. And yet there's still a lot of wildlife that lives there. You go into some of the other boroughs where you have, you know, larger parks, more green space, you have even more animals. But as in all cities, as people develop the land more, those animals get pushed into weird places and then they interact with people in weird ways. And some animals are, you know, have figured out ways to coexist with humans and be very successful at it. In North America, raccoons are, like, ubiquitous, trash pandas. Like, you know, they've been very successful living right next door to people. Bats live in people's houses all over the world. In Saskatoon, we don't have very many raccoons. I've actually never seen a raccoon, but we have these big white-tailed jackrabbits that are all over the place. We have gophers and prairie dogs, mostly gophers, but lots of burrowing things that, and they're all over the place. They hibernate in the winter, but, like, you know that it's spring when all of a sudden all these holes, like, open up and you start to see these little, like, things, these little ground rodents, like, popping up and running around, and they like wag their tails. They're kind of cute.
It's part of their kind of fitness advantage, right? All the city animals seem to be quite cute.
They are pretty cute. You know, there's just a lot of animals that people come into contact with, and that's when people aren't even trying to. Like, so people are out hunting, if they're trading in live animals, if they are even, you know, in some cases working on farms, working on wildlife reserves, hunting. All of these activities bring people into contact with animals, and I think that people just don't really realize that. They also don't realize, and I'm not an ecologist, I'll preface this by saying that, but they don't realize how much human activities encroach on different spaces where animals live, different ecosystems, and how much that disruption increases the risk for spillover of both known and novel viruses. I mean, the good news is for virologists, like, we're not going to be out of a job anytime soon.
Well, arguably, there were enough viruses to study to begin with.
Yeah, it's true. We're never going to get rid of SARS-2, and there's a lot of other viruses out there that might pop up that will do the exact same thing.
Yeah.
And in order to deal with this, we do need long-term, sustained investments. It's not true that we're only interested in funding. We're interested in making sure that our research is an investment that has a good return for humanity. And in order to have that return, in order to actually do our jobs and be successful at them and reduce the risk of viruses emerging and killing us or our pets or our loved ones, we need to have, like, the government make a sustained investment in science and provide us with the support that we need to do the important work that did things like allow us to develop vaccines within a year of this virus emerging. So that's, that's one stump that I'm always standing on.
I think that gives us a very good step to talk about kind of more specifically about the emergence of SARS-CoV-2, and you've been kind of very much involved in searching for the origins of this virus and talking about it publicly on social media. And I think I checked this morning, you've reached almost 500,000 followers on Twitter, which is
I've plateaued though, because ever since Elon took over,
of course,
I have
it's messed up the algorithm, hasn't it?
Yeah, I lost my blue check because I wasn't willing to pay for it. Part of me can't let it go, because especially early on in the pandemic, I thought Twitter was a mostly pretty great community. It was a great place to hear directly from other scientists.
Right.
And I think that one thing that before the pandemic, I knew a lot of virologists, right? But I didn't know a lot of EPIs. I didn't know a lot of ID clinicians. I didn't know a lot of policy people, public health experts, global health experts. And those fields are all really, adjacent to mine. They're very complementary areas of expertise. And I think one of the best things that came out of pandemic Twitter was really helping people make these connections across disciplines in a way that was sort of focused on the greater good. And I've met, like, good friends that I think I never would have met. I've taken vacations with people, like we've literally paid for airplane tickets to go meet in different places. I've had career opportunities because of it as well. And in some ways, I could argue that I got my job at Vito because of a friendship and then a collaboration that I built on Twitter that came about organically with Jason Kinderchuk, another colleague, and now, again, collaborator and friend, who I knew of. I was familiar with his work. He worked on Ebola, but somebody I didn't really know very well until we started basically talking about how much misinformation there was. And this was back in 2020. And now I would argue that there's hardly any misinformation. It's almost all disinformation because it's intentional. And that just makes me really sad more than anything. And I do think that it's worthwhile to continue to maintain my platform, to use it for good, but I definitely use Twitter a lot less. And as you mentioned, Spiros, you want to talk about my favorite topic in the world to discuss on Twitter, the origins of SARS coronavirus 2.
It's arguably my favorite one as well.
Oh, it's the best topic in the world. You meet the best people talking about it, especially the ones who have a different perspective than
That's
you.
the one,
I think that has not ruined Twitter for me. It has been useful, I think, in trying to push back against some of the disinformation on that topic in particular, which, for a variety of reasons that I'm happy to discuss, I think are actually a huge threat to scientific progress. And I'll just, I guess, maybe here's the TLDR. The real problem with that is not so much the idea that a lab leak is or is not plausible. Of course it's plausible. Lab accidents do happen. Was this a lab leak? Are we saying that it was a lab leak because it's plausible or because we have evidence?
Right.
We're not saying that because we have evidence, because there is no evidence to support a lab leak. Why people are saying that is to attack science, basically, and specifically to attack my profession. And of course, I'm a human being, so I'm like, yeah, you want to fight? Like, yeah, stand up, for virology. But that's not the main reason that it concerns me. The main reason that it concerns me is not because it's going to put me out of a job, because it's not. I don't actually do gain of function research, at least not the kind that people profess to be worried about. What worries me a lot is that it will shut down research that is going to be absolutely crucial to understanding how to respond to emerging viruses. And whether that's basic fundamental knowledge about how those viruses work, how they grow, how they replicate, how they spread between people, whether that is how to make vaccines for them, whether that is what kind of drugs will work against them.
Yeah.
All of these things you need virology research for. And if you're saying that all virology research is basically, virologists all trying to like out gain of function each other, like for clout and like for the lulz, like, I mean, that's simply not true.
Yep.
And it makes all of us less safe.
But it's interesting how you've kind of shown both the good and the bad of being on social media during the pandemic, and then kind of talking about all these topics that are, sensitive they've become sensitive because of the attention they get, really. So I was wondering, so what's your, what would you say to an early career scientist who wants to get into more public engagement and kind of social media, but might be afraid of the kind of bad side of things?
Yeah. I'd say, there's different ways to do it. And unfortunately, I don't know of a way to put yourself out there publicly that you're not going to potentially set yourself up to be attacked. Often for no reason. For all the people who don't like me because of like my outspoken Zoonotti ways, or my pro-vaccine enthusiasm. There's people who just don't like me. They think I'm annoying. They think I'm loud. They think I swear too much. They think I'm not attractive enough. They think I'm too fat. Now they're probably going to think I'm too skinny. There's no way you can win. And if you're a woman, if you're queer, if you have, any kind of diverse gender or ethnic or religious identity, you're already going to be a target just because of who you are. And there's unfortunately nothing that you can do about that. A lot of the abuse that I get, even if it's by anti-vaxxers or, lab leak trolls, a lot of it's very gendered. It will say that my co-authors, almost all of whom are male, and I don't think that's an accident, are evil and corrupt, and they've all conspired to like create this narrative at Tony Fauci's behest. And I've done all that stuff too, except I'm also stupid. I'm also old. I'm also fat. I'm also ugly. I'm also like unlovable as a human being. And I don't think that's an accident, that it's because I'm, again, one of the few women who has been in this space. And I know that other women who are my co-authors or who have been outspoken about this particular issue and about vaccines have experienced much of the same thing. I think that, there's no way to completely get away from that. So the more public that you are, the more there are always going to be people who will attack you unfairly and for personal reasons that have nothing to do with your ability as a science communicator. But I will say that it's really important to have a diverse set of voices and views. Believe it or not, like, I actually don't mind it if somebody genuinely thinks it was a lab leak and thinks that they have evidence to prove it. I actually think that we're better off by having multiple perspectives approaching a problem. And I mean, you can see it with my co-authors. You know, it's been very controversial that they changed their minds early on when they were writing the proximal origin paper.
Yeah.
But that's normally how science works. And in part, it works like that because there are people who are sharing their views and their interpretation and how they would, you know, take the data and how they would regard that and what they think that means.
Yeah.
I think that's good. I think that's valuable. If only it were like that all the time. But if people can prepare themselves, especially early career folks, can remind themselves that their worth as a person, as a human being, is not tied to what dumbasses say to them on Twitter. And honestly, people who are trying to be as cruel as possible. Sometimes that's just for kicks. Sometimes that's an intentional tactic to silence people. If you want to be a science communicator and you want to have a broader audience, you have to be prepared for that, but also like know that the more you're getting attacked, the more effective you actually are. When I have lab leakers just say stuff about me that's completely made up, and in my view, it just means that I'm actually doing a good job because people are trying really hard to discredit me. And so for anybody who wants to do more of that, like, there's just no sensitive way to put it. Like, you need to have a thick enough skin, like, to be able to tolerate some of that.
Yeah.
But you can also look at it as a positive thing. I also try, although I'm not always successful, to be empathetic to some of the people who are being particularly personally mean to me. Like I said, I'm not always successful at that, but you know, I've come to understand my limits too, and I think I've learned a lot about myself, which is another good thing about it. Like, I know when I need to take a step back and just like chill a little bit, and not look at Twitter for a while.
And sometimes it's just not worth your time, right?
No, it's not worth my time. Time is I tell my trainees this all the time, and I truly believe it. Time is the most precious resource that you have because it's the only one that you can't get back.
Right.
You can always make more money. You can always, get another grant. You can always redo an experiment, and you can always hire more people. But, I mean, people are very valuable. But your time, we can't hit rewind on anything. Wasted time is wasted time. And, I would rather spend my time thinking about doing good work, doing right by my trainees, doing right by my family, and spending time with the people I love, being happy, and doing something productive and useful.
That's really, really good. Yeah. I think that's with that kind of piece of advice. I think let's try and wrap up then with some kind of ending questions from everything. We've touched on a lot of topics. I think it's been really interesting to go from kind of what virologists like yourself do in the lab and career paths as well. I think to me that's usually the most important, listening to people's career paths and how they're all so different, and it gives you this perspective that you could really go either way. And we've touched about science communication as well, which has been a really big thing, especially in pandemic times. Any other kind of interesting questions?
So, given that you've worked on several viruses, not that you can pick favorites, but what has been the virus that you've maybe pursued the most, or has been the most intriguing personally for you?
Probably Ebola, but Ebola is like such a classic. I mean, it's so cliche, but like, I read The Hot Zone in like the 90s, like many virologists my age, and it scared the shit out of me, even though now I know that that's an exaggerated account of Ebola. So, Ebola's got a special place in my heart. It's why I decided to become a virologist. Why I worked as a technician for 3 years between undergraduate and graduate school at an immunology company. And immunology is fascinating, and it's like one of the hardest subjects, I think, in all of biology. But good old Ebola, like, always got me. And plus, it's a nice virus to work with, not in the sense that it's easy to work with because it requires such high containment. But, and, the West African Ebola epidemic, which was the first really big Ebola epidemic, was heartbreaking. And so that virus has just been with me for a long time. I don't want to trivialize it because, there was a filovirus meeting where, like, I cried, like, seeing some of the pictures that were coming out of Liberia. I, like, even am kind of choking up, like, thinking about it now, because I never forget that these viruses, like, kill people and, like, kill mothers, fathers, brothers, sisters, like, family members, people that you love. And kill them horribly in the case of Ebola, because it's so serious, because it's so severe, because it's so lethal, and because it's so scary. It, to me, is something that's also really satisfying to work on. And from a scientific perspective, having a functional model that really is useful for addressing the kinds of questions about the host response and its relationship to pathogenesis that I want to ask, I think is really exciting as a scientist, even though it's a horrible virus. So I always have a special place in my heart for Ebola and other hemorrhagic fever viruses, but it's like the Levi's jeans of hemorrhagic fever viruses. It's like the original. It's not the original, but it's, it's like the original in my heart. So, but it's hard to choose, because I certainly was very interested in SARS-2 when it emerged, just like I had been very interested in MERS. Whenever there's a new virus, the sense of urgency, I think, even for somebody like me who's not really an outbreak response, but there's a real sense of urgency to do something meaningful as fast as you can about the host response and about pathogenesis, which is a pretty big mystery to solve, like, right away. So I'll let my colleagues who are in outbreak response and epi try to contain the outbreak, but I'll try to figure out how it's killing people. And it's not like it's cool when a new virus emerges. It's not. Like, it's never cool when something new and scary is killing people and spreading, and we don't know that much about it. But it feels very satisfying and productive to be working on something like that when you know that it's an urgent need. You feel like you're really making a contribution. So I hate to pick favorites.
I think that's what science is all about, right? Contributing to, especially, virology and public health science.
Yeah.
Is really all about that.
And, I'd say that even though, obviously due to recent events and the pandemic, like, it's obvious, like, what kind of contribution virology makes, although not to everybody. Some people would say we've contributed nothing good. But I think to many people, it's obvious, what virology and people who study viral pandemics can contribute. But I think that there's also a case to be made for people who are doing really fundamental basic science. Like, I don't know, people who are working on bacteriophage and, like, wastewater. Or people who are working on, other things like algae, I don't know, energy solutions. Like, there's a lot of things that are completely separate problems that are not related to microbiology, and that may not even have, like, people who study salamanders or whatever. Like, that is useful. Like, we understand the world better. We understand the ecosystem in which we live. We understand, like, the biological context of the world. And I think that's really critical for solving, infectious disease stuff. It's really critical for addressing public health, for addressing climate change, for addressing all the problems that we face and our children will face and our grandchildren and blah, blah, blah. So I think that, anytime people are motivated to do science, regardless of the obvious urgency of the problem they're working on, it's good to have more scientists. It's good to have more curious people in the world who are trying to contribute and make a difference.
Absolutely. Well, excellent. I think we're reaching our end time. Any last things, kind of words of wisdom that you'd like to share with our listeners and watchers?
It was zoonotic. No, get vaccinated.
Yep.
Yeah, but I don't think I probably need to tell your audience that. Hang in there also. I mean, a lot of early career researchers listening to this podcast,
That's right.
Grad school and postdoc are really difficult times in your life and career. And you'll continue to have difficult times, but hang in there and get vaccinated. And it wasn't a loud leak.
Well, Angie, thank you so much. This has been a really, really great podcast. And thank you for visiting. Thank you for the seminar. Thank you, everyone, for listening. I think I'm supposed to say we will see you next time on Research Goes Viral. Thank you so much.